talking about different kinds of functions recently, and today what we're going to do is we're going to talk about inverse functions. So the idea of an inverse function is that it's going to be taking, instead of going from x to f of x, it's going to take f of x and give us back x. So the function f and the inverse function, which we note f to the -1, are going to be doing and undoing each other. So they're going to do opposite orders of the same sort of ideas. And one quick thing I want to get out of the way right away is that if we have f to the -1x, which is, again, what I said, f inverse is how we're going to say it, that is not the same thing as 1 over f of x. So these are not the same thing. Saying 1 over f of x and f to the -1, and I know that might be a little bit confusing because in the past we have had said that to the -1 means 1 over. That is not the case this time. Instead, what the f inverse means is that usually, if we have a function, say f of x, right? This is the function we're talking about. What it does is we take some value x, and it gives us some value y. F inverse is going to take that value y and give us back our original x. So if we note it in a way that we've seen before, using our little domain and range blobs, right? Remember the domain and range? If we've got some points here, and we say that they're in the domain, so they're the x values, then each of them are going to map to some point in our range, y, right? So like this one can go there, this one's going to go here, and this one's going to go here. And for now, just for now, we'll talk about this again later, but for now we're only going to be talking about one-to-one functions. If you remember what that means, it means that these points here are only going to go to one point over here. So there's not any point where like this one goes to two different points, and also, because obviously that would make it not a function, right? There are two y values for one x value. But also, and this is where it's important, is that we're only going to have one x value going to each of these y values. So like, for example, we won't have both of these x values going to the same point here. And that's just for now. We'll talk about that again later, what it might mean. So, if this is what f of x might look like, taking us from x to y, then like I was saying, f inverse is going to take us the opposite direction. So instead, it's going to take us from this point to this point, from here to here, and from here to here. So what that means is that the domain of f of x is equal to the range of f inverse of x, and that the range of f is equal to the domain of f inverse. So, I think it'll help if we just run over a quick example using some numbers. So if we look at the same picture again, and let's say we gave ourselves a couple of points, right? So let's say this is 1, 3, and 5, and say it's going to some other points, 5, 10, and 7, right? Okay, so let's say that f of x takes 1 over to 5. So f of 1 equals 5. And let's say that 3 takes us to 7, and that 5 takes us to 10. So that means that f of 3 is equal to 10. And f of 5, f of 3 is equal to 7, and f of 5 is equal to 10. Okay, this is good. So, then that means that, like we were saying earlier, if it's in the domain of f, it's in the range of f inverse. So, when we look the other way, f inverse of 5 is equal to 1. And so you can see how these points flip, right? So just like here, 1 was in the domain, now it's in the range, so it's our output, right? So then we can go through and do the same thing with the other points. And we can see that in each of them, they switch places. So now 7, where it was in the range, is now in the domain. And also 3 flips as well. So where 3 was in the domain, now it's in the range. And so now what we're going to do is we're going to see an example of how this might work with actual functions. So the first thing we're going to look at is what happens if f of x is equal to x cubed, right? Well then, and I'll show you in a second how to do this. F inverse of x is equal to x to 1/3. And the important thing with f and f inverse is that if you'll notice, 1 went to 5, and then 5 went to 1. So we started with 1, and then we ended up with 1. So your initial value, if you plug, remember when we did this a couple days ago, plugging one function into another function? If we do that with the inverse and the original function, we should end up getting x back out. So if instead of doing f of g, we did f of f inverse of x, then what we'll see that we get is that we get x to the 1/3, f inverse of x, to the 3rd. And if you remember your power rules for exponents, if you raise a power to a power, then what you end up getting is the power, these two powers multiplied. And 3 times 1/3 is 1. And so we see that we get x back up. And so that's one of the really important things about inverses, is that if you compose a function with its inverse, you get x right back up. Okay, so now we're going to get into how you can go about solving for an inverse. So let's say we have a function that's just more or less the same as the one we just worked with. Let's say it's x cubed plus 2. Okay? So the first thing we want to do, just for sake of simplicity, is call f of x, we'll just call it y for now. And what we want to do is, instead of having it be y equals something with x, we're going to solve it the other way around, where we have x equals something y. So the first thing we want to do is subtract 2 from both sides. And then the last thing we'll do is we'll take the cubed root of both sides. And so now what we've done is we've solved this equation here for x. And the last thing we do is, because what we usually want to do is we have a function, we like having it f of x, where x is the independent variable. So the last thing that we want to do to this function is switch the x and the y, because they're just variables, we can name them however we want. But we want to keep our nomenclature consistent, where we always have f, or f inverse, or g, or h of x, just because it'll be easier to write things and easier to think about things. So then we switch, and what we end up getting is the cube root of x minus 2 equals y, and this new function is what we call the inverse. Okay, so that's all well and good. What we've got is a simple way to go about, if you're given a function, finding your inverse. You do these couple of steps, you set it, your initial function equal to y, you solve for x, you switch x and y, and you call it f inverse of x. Great. The last thing I'll talk about before we wrap up is what the graphs might look like, just really quickly. We won't get into it too much, but we'll cover that in detail a little bit later. But the cool thing is that if you look at these points, we can see that our x's here and our y's, right? We draw a little table out there. And we see it's 1, 5, and on this side, like we were talking about, they switch. And so, what does it mean if one point is 1, 5, the other point is 5, 1? Well, this only happens in a special case where you draw the line y equals x, and you can reflect one point over the other. So, if this point here is 1, 5, and this point here is 5, 1, you can kind of see, just looking at it, how they might flip. And that's basically how graphing inverses work. If there's a function like this, just some random function, the inverse is going to be the reflection of that over this line. And that happens because every single point on this line, the x and the y coordinates switch. And that's what happens here. Remember, so it was 1, 5, and then it goes down to 5, 1. And so we can see a little flip that happens there. And we'll get more into this in a little while, just, with some practice and some other things like that, just to clarify everything. So this is a basic introduction to how functions and inverse functions work.